guys were here last week and you're now here this week, but it's the same show. This is Howdy Partner, and this is a show where we like to talk about some of the cool things that our partners are doing in the market. And today with me, I have a bunch of new friends. I have Mansi, who also is a partner solutions architect at AWS, and we also have our friends from over from Aqua, who are going to talk to us about all things security today. But if this is your first time tuning in, this is Howdy Partner, and this is a show where we like to talk about some of the cool things our partners are doing in the industry. And so today we're going to be talking about all things security and some of the cool things that our friends over at Aqua are doing to help promote security within cloud native applications. And so I'm a partner solutions architect, and what I do here at AWS is I like to work with our partners to build integrations with our AWS services and also help promote some of the things that they're doing in the market. Mansi, do you want to introduce yourself?
Yeah, thanks, Andrew. Hey, everyone. My name is Mansi, and just like Andrew, I'm also a partner solutions architect with AWS, and I'm really excited to be here with the folks from Aqua today.
Nice. And so just to give some more context for some of the things that we're going to be talking about, Mansi, give us an intro. Give us some more context as to what people can expect from today's show.
Yeah, for sure. So we're going to be diving into DevSecOps, exactly what it is, some of the common use cases for it, where it's useful. So let's actually just dive right in. So to understand what DevSecOps is and why we need it, let's actually take a look at a common DevOps flow. So with a typical DevOps pipeline, things are streamlined and everything is automated and fast. So a developer would check in their code and it would kick off a pipeline, which would typically run some automated tests, maybe build a new version and deploy it to a test environment. And then you'd probably run some more tests within that environment. And if everything looks good, you get the green light to release. So pipelines obviously make application delivery fast without manual effort from developers or testers, which is really awesome. But what about security? So you obviously can't release the new version to production without making sure that it's secure and that it doesn't have any vulnerabilities or expose any sensitive data. So before deploying it to production, a security team typically will go in and test a new version for any vulnerabilities and other security issues. So for example, maybe the developers used a new library that has some vulnerabilities, or somehow something with the new change exposes sensitive data, or the container image has some security issues. And so these are all things that developers might not be aware of. So this is where the security team would come in, and they would usually run some tests and analyze the code changes and look for any security issues within the application. So depending on the complexity of the application, this could take hours or days or even sometimes weeks. And so, the security team could come back and maybe they found like hundreds of issues or vulnerabilities that the developers would have to then go back and fix in the new version. But again, depending on the complexity of the application, let's say that this took a week to do. So with how fast agile development works, the developers could have created multiple new versions of the application while the security team was still testing that initial change. And so this becomes a problem because it creates a bottleneck where you have a super optimized DevOps process, but just before the release, the security check blocks the whole process and delays the release. And so this would slow down the entire DevOps cycle. So obviously we need a way to fix this bottleneck. So this is where DevSecOps comes in. So if you're able to integrate the security directly into the DevOps pipeline, then this would solve the problem. So instead of thinking of security kind of as an afterthought and doing the checks after the new feature is developed and tested, you would want to integrate it directly into each step of the DevOps process. So DevSecOps basically just bakes in security at every phase of the software development cycle directly into the CI/CD pipeline. And it does it by doing things like creating security policies and incorporating automated tools that would detect security issues directly into the pipeline. So this can include things like code quality scans, other security scans, and any other security tests that you would have to run for the application. So basically, on every commit, the automated security tools in the pipeline would run, letting you know of security issues right away as you're developing instead of waiting all the way until the end. So with this, it lets you develop secure software and applications in an agile way without having a security bottleneck, which is really awesome. And so with traditional IT security, securing your application usually involves building a wall around it, around either the application or the infrastructure. So a good example of this might be like a firewall, for example, where you're blocking security threats from the outside. But with cloud computing, and as we migrate more to using containers and microservices, security gets tightly integrated directly into the infrastructure and the application. So, like I mentioned with DevSecOps, with cloud native security, there's continuous application security instead of just building a wall around your application. So, like I mentioned, the security is built directly into the application that you're working to secure. And this can apply at multiple layers, going from the operating system to the container to the application itself. And then you can also automate fixing the vulnerabilities throughout the pipeline. So cloud native security is really awesome. And the way to do it is to integrate the security directly into the pipeline. And with that, I will hand it back to you, Andrew.
Nice. Thank you for that. So I think it's important to understand, because if you take a look at tech Twitter, I feel like DevSecOps has literally become like the biggest buzzword like in the industry right now. And I think that people fail to really understand like how important it actually is, especially like when you're running things in production. And so another, I guess, example I can show based on a book I read by Liz Rice. I doubt she's watching this, but shout out to Liz Rice. Is she, in her book, she actually shows a really good example of all the different areas of vulnerability that one of your containerized applications actually expose. And so if you take a look at this picture she provides in her book, I know for me personally, like, these are a lot of things like I didn't really think about when I was learning about container security, or really just security in general, when it comes to microservices and things like that, right? And so if you just take a look at this picture, there's a lot of areas of focus for someone attacking your application that they can take advantage of, right? And so I think it's really important that when we talk about things like DevSecOps and really just security best practices, to like take into consideration exactly how many different areas of concerns that there actually are when you're securing your applications, right? And so I think the way Mansi just described what DevSecOps is something that people should really take the time to understand, because it's not just a buzzword. It is something important. It is something that people really should learn more about. And so again, just bake this image into your mind when you're securing your application, or for the next like security review you go through, because at the end of the day, these are the things that you want to take advantage of. So with that said, Mansi did a great job of showing us, or talking to us about exactly the importance of DevSecOps and the different things that you should be taking into consideration. But with that said, we have our friends from Aqua to take us a little deeper into some of the things that Aqua is doing to help promote DevSecOps and the different security things that they are doing in the market today. So Grant, Samar, thank you for coming on the show. Do you guys want to introduce yourselves?
Sure. Thanks for having us. My name is Grant Seltzer. I'm an open source engineer at Aqua Security on the open source team. And for the most part, my job is to help maintain Tracy and libbpf Go, as well as engage with the community about those projects and BPF in general.
Hey folks, I'm Samar. I also work with Grant on the open source team. And I've been on different projects so far, including Tracy, Trivi, Cube Hunter, and a bunch of other Aqua open source projects. And at the moment, I'm looking and working on Tracy primarily.
Nice. And so before we go into Tracy, I think it's really important for folks to understand exactly what eBPF is. So you guys can you talk to us exactly what eBPF is, kind of why it's there, and kind of why it's important in today's climate?
Sure, I can handle that one. So, right, so BPF is definitely another one of those really big buzzwords. But essentially, BPF is a Linux-specific technology, and it allows you as a developer to load these small programs into the Linux kernel that execute at or in a secure sandbox environment. There's a BPF virtual machine inside the Linux kernel. And the way that you run those small programs is by attaching them to various hooks. So you can attach them to kernel functions. So every time that kernel function is called during the execution of the kernel itself, your BPF program will trigger, and it has access to certain points in memory or relevant data that you may want to use. You could attach them to system calls. You could attach them to user space programs. Maybe I can show a demo of that a little bit later. And another big use case for it is in the networking world. You could attach them to network sockets or something called XDP. You'll hear a lot about that when it comes to BPF. But essentially, it's kind of the standard way that a lot of people like describing it, or the analogy a lot of people like to use, is comparing it to what JavaScript does to HTML, BPF does to the Linux kernel. So you could kind of ad hoc add logic to it.
Nice. And then I guess before we go too deep down there, I know Aqua does a lot of cool things. You guys have been doing a lot for the security community in general. Can you talk a little more about Aqua, kind of what you guys do and focus on?
Yeah, I can take that one. So at Aqua, we've been, focusing on making products that help you and your workflow be more secure. And we basically want you to not think of security as an afterthought, but rather make security as a building block when you design your software. So a lot of the open source projects that we have today are kind of keeping that aspect in mind and trying to shift security as much as to the left as possible. As Nancy mentioned earlier, it's quite important to be able to proactively, manage security and the risks that come with it. And the sooner you do that, the better it is for everyone. So at Aqua, we've come up with Trivy, which is a vulnerability scanner that can scan your Docker images or any other kind of images that you might have and find vulnerabilities in there before you put it into production. We have Starboard, which integrates Trivy and makes Kubernetes deployment secure. And then we have Tracy, which we're going to be looking into today, that takes advantage of the eBPF technology and makes it super simple for someone who may not even be familiar with BPF and help them secure their pipelines.
Nice. And I think one thing I'll call out too is I feel like the more that a lot of these technologies evolve, it almost feels like you're just adding layers and layers of abstraction on top of kind of what already exists, right? And so I think when you add those layers though, you also introduce a lot of more security vulnerabilities. So I think it's really important that we kind of talk about kind of what those vulnerabilities are and exactly how tools like Tracy help to kind of solve for those types of problems. Because I know before Kubernetes came out, right, it was just things like Docker Swarm, Docker, or just using containers. But once you add that layer of abstraction, there's a whole slew of issues that come with that, right? And I think it's really important to have these types of tools to make sure that we can secure those vulnerabilities as soon as they happen, right? Or even discover them before they even become a vulnerability, right? So with that said, talk a little more, Tracy. What is Tracy? What was the motivation for starting this open source project? Tell us more about that.
I could jump in, sure. So, right. So Tracy itself, it does use BPF under the hood. It's sort of, I think the oversimplified way of describing it would be kind of like antivirus for the cloud. I might get some flack for saying that. So never mind. So it's like a runtime. It's a process that you can run on any Linux machine that supports BPF, and it detects everything that's going on, whether it's system calls or various different security events. Soon we should have some type of networking events And to detect all these things that are going on, you can decide what you want to filter for based on the event or things like UID or the process name. And you could do a lot of things with that. So you could apply security policy on top of that. You could do things like capture executed files and integrate it with a whole bunch of different things. I could actually give a demo of what running Tracy looks like, or I could also talk about the use case for it.
Okay.
So like in terms of use case, security is the most obvious one for us. We're certainly a security focused company. So, some examples of why you might want to use Tracy is, let's say you want to know every time a new process executes on your Linux production environment, virtual machine. If you want to know anytime new memory is allocated, or if the memory protections change on a region of memory to make it executable, every time a file is accessed, if that's something as an SRE or as a security person or just any developer, if you would want to know that, Tracy enables you to do that. We've also seen it used for running forensics. So you can use Tracy in some sort of sandbox, run a potential piece of malware, and use it to determine what's going on. So it's still a relatively new open source project. It's fully open source. We develop in the open. All discussion is done in the open on GitHub. But yeah, there's certainly a lot of use cases that haven't been tapped for it yet.
No worries.
Yeah.
I think we actually have some questions in the chat about Tracy. So I think the first question I see is, what standards or libraries are those scanning tools referencing?
Was that for something that Samar brought up?
Yeah, I'm just trying to. Yeah, it's all standards libraries. I think I'll just take a shot at it. So it's so Tracy is has two components. So one is obviously the eBPF code, which is written in C, and there's the user space components, which is written in Go, and we also have Tracy rules, which we'll talk about later today, which is basically like a rule engine which can determine what kind of basically you can pass in or you can build signatures or heuristics that you think are synonymous with a malicious activity, and then it can pick up events from Tracy eBPF and show you what exactly is happening. So if there was a fileless execution, if there was an anti-debugging activity that happened, or any of that stuff, if there was a malicious reverse shell that was open, it can tell you that. So I hope that answers the question. But yeah, feel free to leave a clarifying follow-up question if it didn't. Okay.
Sounds good. And then before we go into a demo of Tracy, Mansi, who are we? What are we doing here? And what are all these crazy terms we're throwing out? What is the purpose of the show again? Oh, I think
Sorry,
I
can you?
there you go. Sorry. I do it all the time. You're good.
No, so we are a Howdy partner. We like to have partners featured on here to showcase their products and have them show us really cool demos about their products.
Cool. And so with that said, yeah, let's get into Tracy.
Sure. Let me share my screen. So here I am in the Tracy repository. Like I said, you can find it on GitHub. And there's kind of two sub-projects of Tracy. One is Tracy eBPF. That's what I described a couple minutes ago. That's what
Oh, sorry, real quick. Can you actually zoom into your screen a little bit? I think some people are having a hard time seeing.
Oh yeah, for sure. How was that?
Looks good to me. But let us know in the chat if we need to zoom in more.
Yeah, happy to do that. So like I said, ETF is what I described, sort of that engine for detecting all of those events. And then we have Tracy rules, which is, as you might guess, a rules engine on top of that. So you can create policy for seeing all those events come in and determine when you want to create some sort of alert on top of that. But for now, there's a ton to unpack. So I'm going to talk about Tracy BPF and demo that for now. So in terms of what it's built with, it uses Go. You know what? Let me actually run it first. So what I just did here, I'll do less. These are all the different events that we have BPF programs that can that you could attach to. So for example, here's a bunch of system calls. So read, write, open, close, stat. If you're unfamiliar with system calls, let me actually just briefly describe that. It's essentially the API into your operating system. So anytime you read from a file, or essentially anytime you read from a file descriptor, it's going through the read system call or some variation of it. Anytime you're writing to a file, it's going through the write system call. Things like if your process needs more memory, you're probably not calling it directly, but you use mmap to do that. And there's hundreds and hundreds of system calls, a lot of security implications of the system call layer that there's a lot of different protections that you can use, like capabilities and whatnot. But Tracy is purely just trying to tell you when they're used. Other things that Tracy can detect are like there's things called LSM hooks in the kernel that are put at very strategic points. So, for example, sorry, there's actually a lot. So anytime a socket is created, you could find out about that using LSM hooks, which Tracy makes use of. Ton of different events, and using this Tracy eBPF list command, you can take a look at all of them and their arguments, and you can actually Tracy eBPF will actually list these values for you when it's running. So let me actually run it. This is without any filters, so I'm just going to kill it right away because we're going to get a whole lot of events. But here's one example that we see that at this timestamp, UID 1000, which is just my user. PS was called. This is the process ID, I believe. Process ID. Sorry for the infinite token. Here's the actual event, security file open, the path name that was used, and the flags. It looks like it was a read-only and a large file flags were used, the inode number. So it's a whole ton of stream of events. Let me see if I could find one that's actually useful that could apply.
And then just real quick, were you just running this on your local machine, or where were you running Tracy off of?
So yeah, that's actually a really good question, because you can notice that this is a Mac. I'm running this in a virtual machine.
Okay,
so yeah, Tracy or BPF and therefore Tracy is very much Linux specific. You could do things like, here, let's actually look at the help text. We have different integrations. Like you can have, we have for output, you can output to a webhook. You can output in different formats. Really, the one that I'm showing you is kind of for demo purposes. I don't know if anybody is just going to turn on Tracy and just look at it. That's
right.
If let's say like a SOC analyst is doing that, maybe not the best use of their time. But we could also do things like, here, let me find a good example. So we can specify a particular UID. So the UID equals 0. So if you're unfamiliar, UID 0 would be root. So you could see here that I have some privileged processes that are running, and it's for accepting on a socket file descriptor, various different processes. So this is SSSD. I think that's something to do with SSH. I'm not entirely sure. You could do things like pass another trace flag and do event equals TE. And let me open up so what I just did is I switched tabs, opened up I'm going to make it bigger, opened up a root shell and just executed ls. So we could see here, along with the Z shell executing a whole bunch of stuff for my theme to work. But you could see here I did sudo Z shell, as well as everything else that I then executed, which are behind the scene things that my shell is doing. But that's just like one example of how we can see like everything that's happening or any process that root is executing.
Okay, and then can you actually output this to like, I don't know, like if let's say you're in like a Kubernetes cluster and you're using like Prometheus and Grafana for basically all of your tracing, right? Or to output whatever you're tracing to, right? Can you do that with Tracy, or can you talk to us a little more about
that? So to be honest, I'm sort of like lower down in the Linux world, and I'm not a big I don't know that much about Kubernetes or Prometheus and how it would work, but I assume that there is very much a way to do it. Like you can output in JSON format and to a file. Right. I don't know if that's how those platforms typically sync. I'll let Samar answer this one actually.
Yeah, I can jump in. So with Tracy, we also have the ability to define your custom template. So let's say you're writing a new piece of software that accepts a new file format standard, which is not JSON, which is not an existing format. In that case, you can define template file, which is basically like a syntax of how you want your stuff to look like, and it's essentially a Go template that you can pass through, and the output of Tracy will change according to the template that you pass in. So let's say you wanted to show JSON, and I can do a real quick demo here.
Yeah, that'd be great. For
so that you can, yes. So you guys can follow along. So.
And then could you make your screen just a little bit bigger?
Okay. All right. How's that?
Yep. And then let us know in the chat if it's too small. But I can see it. You should be good.
Okay. So right. So you can see another option that we have with Tracy is how do you want to see the output? So let's just quickly dive in and see what we have here. So you can see that you can output as JSON. You can output, as I mentioned, using according to a custom template. So let's say, you've defined a template that suits your needs, and you wanted to output it as such. Then Tracy will output in that format. So if I quickly show you folks how this will look, you can see this is exactly the same output that you saw before, but in a JSON format. So I think you get the idea, like, you can define your custom format by passing in a template, and then whatever format suits your needs, Tracy will output accordingly.
Nice, because I could totally see if I was like a developer, or if I was even like a sysadmin that was overlooking basically all of my organization's outputs and files. Like, I could see how it would be really helpful if I could just have it all in like a singular place. So that's the reason why I asked. I was just curious.
Yeah,
but aside from that, what are some other features of Tracy that people should be aware of if they're evaluating the tool for their own use cases?
Yeah, so I can show a few interesting use cases. So as we mentioned earlier, Tracy is a security-focused tool, but it's also a research tool that you can not only learn from, not only use from, but also learn from. So in this case, let's take a look at a use case where you've set up a honeypot server somewhere. So honeypot is basically, in simple terms, it's a machine running out in the wild, accepting all connections and basically acting as a pot of honey for people to come and try things with. So let's say you wanted to run a machine out in the wild, and you wanted to see what happens if you leave a machine open with all ports open, no firewalls, no nothing. So let's say you run Tracy on it, and you want to see what kind of things are people doing by SSHing on your machine and running commands. So one feature that Tracy has is to capture artifacts. So let's take a look at the help. So Tracy can let you capture all the executables or files that were written or anything that you want into a safe place for forensic purposes later. If you wanted to see, if you came in after the fact and you got a bunch of logs, but at the same time you wanted to see what exactly was part of that executable that ran on your machine. So Tracy can capture all the executed files and put them in a safe place. So let's see this in action. So let's say I run Tracy as such, and then let's say I run, ls to list my files. So you can see Tracy has captured that as an event, but also Tracy has not only done that, but it's also taken the process that was executed, in this case ls, and placed it out into a directory for you to come and later on investigate what all stuff ran on your machine. So in this case, you see that I run ls a bunch of times. I ran clear to prepare for my demos, and you can also see I run Python. So this is very handy in case you want to see what exactly is running on your machine. Taking a look at events is nice, but let's say you wanted to reverse engineer and open the executable in IDA or something, and then that way you can take these artifacts, load them up, and reverse them yourself. So that's one nice feature that we wanted to show you. And yeah, there's as Grant mentioned earlier, Tracy is comprised of a couple of things. So far you've seen Tracy VPF, which is the pure C, Go, and eBPF side of things. So capturing events, capturing artifacts, and all things related to eBPF. But there's also another component to this, which is Tracy Rules, which is our rules engine, which sits on top of Tracy and makes decisions based on the events that Tracy eBPF captures. So, I can dive into that, or if there are any questions outstanding, then
yeah, I actually have a question.
Mm-hmm.
So I mean, this is kind of an obvious one, but let's say like one of your engineers gives themselves like pseudo privileges, and they start doing some weird things, but Tracy's running. Does Tracy have the ability to also alert or send alerts if something like that were to happen?
Yes. So that's a great question, which also ties in with the next piece. So Tracy does have that ability today, and that is part of the Tracy Rules engine, or Tracy Rules in short. So Tracy Rules is basically a rule engine which sits and consumes or acts as a consumer of the events that you just saw on my screen. and determines what exactly is taking place. So we have a notion of signatures or rules that you can define or anyone else can define. And let's take a look at that really quick. So Tracy rules is here, and out of the box it comes with a bunch of available rules, and these are open sourced, as you mentioned, and they come out of the box. So in case you want to see if someone is loading a kernel module, which could be done on purpose, but also could be malicious. Or let's say if someone is purposely doing code injection into another process that you have on disk, Tracy rules can capture that. So these rules are essentially defined and captured behaviors of what such a malicious event will look like. And because we capture all events, it's easy for us to get a trail of or a sequence of events to be able to build this timeline and analyze it in the rule engine. So that's how we're able to do this. And yeah, I will do a demo of this today. So if there are more questions, I can take that, or we can jump into the demo.
Yeah, let's jump in.
All right. So okay, so in this case, let's see how we can run both Tracy eBPF and Tracy rules. So for the purposes of this demo, I'm going to use the JSON output as you saw before that comes out of Tracy eBPF, and I'm going to pipe all the events that get generated into Tracy rules. Input Tracy is a flag which basically tells Tracy rules where to expect events. So in this case, I'm expecting them on standard input. And I'm telling Tracy rules that the format of the incoming events is going to be JSON. So now Tracy eBPF is running in the background, and so is Tracy rules. As you can see, it has loaded the signatures that you saw before. And now it's just waiting to analyze the events that it's receiving. So right now, nothing's happening.
And then just real quick for people that may not be as familiar, what is the purpose for those loaded signatures? So as you can see TRC1, 2, 3, and so on.
Right. So the purpose of them is to determine abnormal or behavior that is categorized as malicious or could be malicious in some sense. So you can see a bunch of defined signatures that we have that come out of the box with Tracy rules, and these are the ones that you can use out of the box. But it's also possible to write your own signature in both Go and the Rego programming language. If let's say you wanted to track and a behavior that you think is worthy of looking. So yeah, those are the signatures that have been loaded. Does that answer your question, Andrew?
It does. Thanks.
Okay. All right. So okay. So let's see. Let's try to do fileless execution. So basically, fileless execution, as the description says, it's basically executing a process from memory, without actually being there a file for it on disk. So when you execute ls, you're executing a file, which in this case seems to live in user bin ls. So this is all good, but people are getting clever and they're aware of the fact that programs like Tracy are on the lookout for malicious executions of various files. So if there was a malicious file, Tracy will be able to catch it. So people are becoming clever and they're writing programs which execute a process from memory. So I have a demo repo here, and shout out to the creator of this program. I've taken this from GitHub. I have not written it myself. It's just an example program to have a POC for fileless execution. So what this program does is it basically creates a copy of your binary or the file that you have on disk and mix it into shellcode. So you can basically, by shellcode, I mean you can essentially execute your program all in memory without ever having a trace of it on disk. So I already have the Python script available. So this is, in this case, the shellcode of the ls executable. So I have this is how I executed. This is how I generated the output. So now fileless py is essentially a Python script that is going to contain the logic or the actual content of else, and it's going to execute that from the from memory. So let's see what happens in the case we try to execute this. So I'm going to run Python, this Python script with the Python interpreter, and you can see
Oh wow! Yeah.
right away that Tracy rules detected the execution that was happening, how it was executed, which host it was executed on. And in this case, there's no data available with this event, so that's fine. But you can see that someone tried to run WC. You can do the same with another command. So let's say I wanted to run ls. I can do that as well. So let's just call it for what it is. So I will create a copy of ls and I will try to run. And you can see again, Tracy Rules was able to capture this. And to the average user, this is just going to look like a normal ls. Like there's no difference between running this ls from memory versus the actual ls executable. But behind the scenes, someone could have injected a malicious payload that ran as you ran the script. And you will not see that on disk, but Tracy will be able to capture this kind of malicious activity behind the scenes.
Okay, and so I guess I have another question. So for example, like, I don't know, let's say someone like gets into your system and they try to elevate privileges and try to get sensitive information from like /bin or like /etc, those directories, and Tracy catches that. Does Tracy also have the ability to completely block them out once Tracy detects that happened, or is it simply just going to tell you that happened? Then do you then need to go and then figure out like what's going on in the background?
Right, that's a great question. So Tracy, as it is not an enforcement today. It doesn't do any kind of enforcement of blocking behaviors. But I do have a demo that I'd like to show later about how you can use Tracy to make decisions in your pipeline where, let's say you detected something malicious and you wanted to block the deployment of that pipeline, or let's say you wanted to block a pull request from getting merged in to your repo because that pull request introduces something malicious into your code base. Tracy is able to do that. So
that's awesome.
Stay tuned. Yeah,
for sure. And before we get to that, I think we have some more questions in the chat. Mansi, do you want to go ahead and go down the list?
Yep, let me go through them. So one of the questions that we have is asking if these signatures, is this signatures following the emitter attack vectors?
They certainly fit in. Like I'm sure all of those signatures that come with Tracer rules fit in somewhere. I don't think they were made or written one-to-one correspondence with them, but it's certainly a good question. And like Samar said, it's worth pointing out again that we designed Tracy to be very much like open source and not just like an open source offering that is just like a sample of a commercial product. Like I'm sure at some point it'll fit into the commercial product, but we really made it extensible, so it's very easy to write policy. So let's say, for example, you want to know every time a very specific program with the binary a very specific path was executed, then you can write a very simple like what's it called, a signature to check for that, and that's using Rego, or you could actually use a Go module as well. We
Right.
enable
Nice.
both.
Right. Yeah. So I just wanted to add to that what Grant said. You can use the signatures that you have today. You can also create your own signatures, and it's very simple to do so. We have example signatures of, like a boilerplate of what a signature should look like that you can take and write your own logic on top of. In addition, all the signatures that you saw today are open sourced, and you can take inspiration from them. They're written in both Go or Rego, which is rules language, they're completely open to how you want to customize. And going back to the original question of MITRE classifications, yes, the ones that you're seeing here, some of them do have like defined classification IDs in MITRE attack lists. So like code injection, for example, is a well-defined MITRE attack technique that is listed and is part of the MITRE attack database. So yeah, they're not like anything custom, but they are actual real malicious behaviors that exist today out in the world, out in the open.
Nice. And so before we get to the demo, if you're just not tuning in, or if this is the first time joining our stream, this is Howdy Partner, and this is a show where we like to highlight a lot of the cool things that our partners are doing in the industry today. And today we have Aqua, and right now they are walking us through the open source project, also known as Tracy. So again, if you want to know more about Tracy or know more about the show, we'll include links in the chat very shortly here. But other than that, Smart, I think you had some more juice for us for Tracy.
Yeah. So right. So I showed how you can see signatures getting triggered with Tracy rules, which is a rule engine. And then there was a great question that was raised by Andrew, how we can block these attacks from happening, and prevent them from happening as we see them. So I just want to share my other screen and show you another cool project that we've kind of built on top of Tracy. So let's see where the screen is. All right. Let me just resize this. Okay. All right. So yeah. So I just wanted
actually,
to...
could you make that just a little bit bigger?
Right. So I just wanted to... so the fact that I have on my screen, we have a documentation website for Tracy that you can go through and familiarize yourself with all the different components. We also have a video that Ty has kind of made, and that's available on YouTube. Ty is one of our friends and coworkers on our teams. And yeah, there's a bunch of documentation that you can read. Yes, so let's get into a project that we built on top of Tracy. So as you know, security is shifting left. It's better to find out stuff that happens out in the wild before it actually hits your production environment. So we thought of an idea where we can essentially take Tracy and all the superpowers that it brings with itself, and take it right where code gets created. So we took Tracy and we put it in GitHub. Essentially, this is what a gist of this project is. So to dive into it, basically what we've done is we've taken the guts or the Tracy eBPF program, and then we've accommodated that into a GitHub action. So as you know, or just like a 2-minute recap of what GitHub actions are, they're essentially programs that can run in your GitHub pipeline when you, let's say, merge a pull request or create a pull request in order to merge it. And then these are essentially small checks. If you're familiar with Jenkins, Jenkins is another CI tool, and GitHub Actions is essentially another CI and also CD that can help you run your unit test as you've created a pull request in order to merge it, or it can do linting on your code and so on. So we created a Tracy action that can essentially check for any malicious activities or behaviors that get introduced as you have created a new pull request. So this is quite common in an open source project where let's say you have a very popular project and there's a new contributor that wants to add new functionality into your open source project. And that's great. We all love external contributions, but sometimes it can get tricky when, let's say, someone has introduced new dependencies as part of their pull request. So this is a short overview of how it looks. So let's say this is a YAML file which you can write in order to configure a GitHub action. Pretty standard stuff. The only thing that you can see here that's different is that we run Tracy in profiling mode, which is another use case and another feature that Tracy has. So you can run Tracy in the background. As you saw, it collects events. And it also keeps a track of what it has seen, which files were executed, how many times they were executed, and what sort of any additional metadata that those files may have. So let's say this was your CI pipeline. And the first step in this case would be starting Tracy. And then you go on with your pipeline as usual. In this case, I'm doing nothing but sleeping in my pipeline. And then when you're done, you basically stop and check for Tracy results. And we'll get into those options in a few moments. So let's say, this is my example project. So as you can see, there's really nothing in here that's useful. It has a README file. And then there's a profile, Tracy profile file that it has generated in the past. So let's take a quick look at that, how that is. So as I mentioned, Tracy can be run in profile mode. So when you run Tracy in profile mode, it basically creates a profile of like the things that I saw when you ran Tracy. So in this case, our pipeline ran bash, it ran curl, there was something that ran Docker, and as you saw, I was running the sleep command in my pipeline, so there was sleep. I ran 20 times. These are the file hashes of the actual individual files. So you can see, if like what's the SHA-256 hash of the file that was executed. And this will be more useful when we see on later. So let's say, someone has so let's say someone has made a pull request, and on the surface it looks like they've added an extra line of README, so that's all good. And this is just a demo example, so obviously it's for demo purposes, but let's assume that this is what a pull request is that you got from a contributor. And as you can see, before I can merge this in, I have scheduled the Tracy CI pipe or the GitHub CI pipeline to do a bunch of checks on each pull request that gets created. So in this case, I've configured Tracy using the YAML file that you previously saw, and it has failed. So let's see why it has failed. As you can see, Tracy sets up itself, and then Tracy is running. Tracy is looking at stuff, and then you go on with your day and you execute the stuff in your CI pipeline. And after the fact, it finishes. It is able to check for any differences that it saw based on the existing profile that you have, which you saw before, and any new things that happened in this invocation of the pipeline. So as you can see, there were differences found, and obviously what we expected to run in this pipeline didn't run. There were differences that were found. So as a result, Tracy failed this build. It said, well, there's something unexpected that has happened in this pipeline. I don't think it's safe to merge this pull request in. So as a result, I'm gonna stop this from being merged or show the maintainer that there's something different. So in addition to that, Tracy action also creates a pull request to show you the differences that actually happen when you're running your pipeline. So you can see here, we had a profile file before that you saw, and now that we ran the CI pipeline again, that profile has changed. You can see I expected curl to run 20 times, but for whatever reason, curl has run 10 times. It could be the other way around as well. If you, let's say, expected it to run 0 times and you never expected curl to be part of your CI pipeline, and you saw there was a malicious curl, reaching out to an address that you had no idea of, which there have been attacks in the past and quite recently, to be honest. This is a good way to see that difference in your pipeline. You can see, the execution time of when this executable was created is different, which is another difference to note. So, someone could have created a copy of curl that was malicious inside of your CI pipeline, and in that case, that would be a different version of curl from what you had expected. So it's gonna send you this pull request to the branch, and it's gonna tell you that something's up with the latest pull request that you were looking at. It's also going to show you a neat little help message of like how to read the profile that you're looking at. So as I was mentioning, it's going to give you a timestamp and a file hash and path to the executable and so on. And if you think this is the new normal, if you expect these changes that you've seen to happen, then you can merge this pull request in, and it's going to update the profile. So the next time Tracy scans your pipeline, it's going to use the updated profile to make a decision based on if it should fail the build or pass the build.
Samara, yeah. I kind of thought that you were going to tie that into like the program that this pull request was to, is like executing commands from the README, and foo was a malicious binary somewhere in the environment, and like show all this crazy stuff. But still, still an awesome demo. I haven't seen that before.
Yeah, thanks. Yeah, there'll be two of this demo.
Yeah, and that really ties into what Mansi described at the beginning of even something like this, that is this very mundane change that you wouldn't expect anything of. To have that as part of your CI/CD pipeline, you don't have to do it manually. You don't have to worry about it ever, and especially to have the actionable item like automatically created is where the security industry really needs to go. I think adding on to the DevSecOps idea of having security integrated into CI/CD pipelines and into the development process is really that it should be easy to use. Things should be actionable, and security control shouldn't break anything. So I think that's like what Sumar, what you just showed. It really shows that like that's really what I think Aqua values, like with Tracy, with Trivy as well.
Right, and I understand this was a lot to take in. So I've written a blog post on the Aqua blog that basically explains in much more detail of what I just went through and how you can use Tracy action in your own pipeline. So I can leave a link in the chat if people want to check out. And yeah.
Nice. And then just going back to the demo real quick. So basically, once Tracy detects that change happened in the README where it's like quote unquote malicious, once you merge that PR, does Tracy then go back to your profile and update the settings so that if you were to run it again, it would catch that similar, I guess like that bug, if you will? So it's not something.
Yes.
So basically, what I'm asking is that you wouldn't have to go back manually, update your profile, and run it again. Tracy would do that for you.
Yes. So it will use whatever the latest is that you've accepted to be the new normal.
Nice, solid, awesome. So aside from that, anything else about Tracy that people should know about, or anything else that you would want people to know about when it comes to Tracy?
It uses BPF.
It sure does. I was actually just scrolling through your guys' GitHub, just out of curiosity for other open source projects that you guys are working on. Are there any other open source projects that you guys want to call out? Because it seemed like there is actually quite a bit. So just wanted to ask.
Yeah, we can. I mean,
we got time. So
on the train of shifting left your security posture, we can show a bunch of other demos as well. So I'll quickly introduce Trivy and its associated projects. So let me share my screen again.
And as you can see, as soon as I mentioned more open source projects, my dog woke up and now he wants to join the stream.
Yeah, so I'm so used to like typing in Tracy because that's the project that I'm working on right now. Like I've almost forgotten about Trivy, but yeah. So Trivy, like you mentioned, is another open source project from Aqua. It's a vulnerability scanner that is super simple to set up and super fast to run. It is another way to kind of like check for vulnerabilities and see what do you have in your Docker image or your Git repo or even your file system if you have if you only wanted to check what's going on there. This is just like a quick GIF of what's there, but as you can see, it will show you all kinds of vulnerabilities that happen. That might be part of your packages, your dependencies in your projects, and so on. So you can run this manually on your own on your laptop as you're developing software, or you could take it a step further with the VS Code extension. So this is kind of neat because let's say you use VS Code for development. You're writing a project that you have, and you just quickly wanted to run Trivy, and you don't want to leave the environment. So you can run the Trivy extension from within VS Code to run a scan on your repo that you're working in, and it's going to show you right there if you've introduced any vulnerability as you've been developing your project. So this is like as close as it gets to writing code and being able to detect security vulnerabilities as they happen. Another step that we've taken along the lines of the GitHub action that you saw before is Trivy action. So let's say you wanted to run Trivy in your GitHub pipeline. How's that going to look like? So you scan the Git repository that you have at hand. And if there are any vulnerabilities that are introduced as you have made a pull request, or you can even run this as a cron job. So like periodically you can see every 12 hours if there's a new vulnerability that has been detected in your repo, it's gonna call that out, and it's gonna give you an output and show you that your project is now vulnerable because of this vulnerability that was introduced in one of your projects that you're using. So yeah, that's like a couple of examples of shifting left and using Trivy that you have. Anything you want to show, Grant?
I mean, really, the main project that I work on is Tracy. But another thing that is related to Tracy is libbpf go. That's the library that we use for interacting with the BPF subsystem from Go code. I could talk a little bit about that, but that's not exactly conforming to the or on topic in terms of.
No worries, no worries. We have the time. Let's do it.
All right, yeah, sure. Let's see. Go ahead and share my screen. I also did want to highlight, after this, I'll highlight a couple things that we did recently in Tracy. But so like I mentioned, libbpf go is another one of our projects that's very much related to Tracy, and I think the main challenge in the BPF world, it's really this really hot technology. A lot of people like talking about it, but I think a lot of people, when they start playing around with it, realize that there's a lot of complications. There's a lot of different choices for how you interact with BPF, and some of them are not very well maintained. There's no documentation whatsoever in the world of BPF. Like it's right. Actually non-existent. So really the way that I learned about BPF is by reading through Tracy's code and like becoming a contributor to it. And that's how I'm now working on it. But there is an active community around it that is very helpful. I will say that. So what we and really a lot of this work is from my coworker Yaniv. Did was create yet another Go library for interacting with the. But this one's legit. This one's good. For interacting with BPF, and it's actually it's called libbpf go. You know what? Let me actually pull up the repository on GitHub, and I promise I will make the text bigger. So it's libbpf go, has this really cute logo, and it's a Go wrapper around libbpf. libbpf is a C library that's maintained in the Linux repository, in the Linux kernel's code, and libbpf go calls into that. So what I can show is an example of using it to attach a BPF program to a user space function and show that running. If you'd be interested in that.
Yeah, for sure.
So there's three different parts to this, and I'll make this bigger, but I'm going to explain it before I start diving into the code. There's three different parts to BPF code. So there's the BPF code itself. there's the thing that you're attaching that BPF code to, and then there's the user space program that's sort of orchestrating everything. So starting with let's start with the BPF code. So if you're not familiar with BPF, it's literally just this is a full BPF program, what I've highlighted here. And what this is going to do, or the point of this, is to attach it to a U probe. And I'll talk about U probes in a second. But all this is doing is using a ring buffer, which is a way of transmitting data from kernel space to user space. It's just sending just a number, just a constant value. This is not very useful. It's just sending some data to alert the user space program that the eBPF program ran using a ring buffer. And like I said, it's attached. We're going to attach it via a U probe, and that happens in the user space code, which is what uses libbpfgo. So we compile that BPF program. We have a BPF object file, and we're going to attach it down here, and this code is all in the repository, and I'll show that after in the GitHub repo. But we're going to attach it. You specify in this little program, you specify a path to the binary. You specify the name of the function, which in this program I translate the function to to an offset. It's like a memory offset, and then just prints out every time it was called. So in this case, this test program that we're going to attach it to. So and here is more of a high level. If I lost you, which don't feel bad if I did, because I pretty much just rambled on for a second there. Is, let's say you have some Go program, no matter how complex, and you want to know every time a function in that Go program is called. So maybe I should have started with this. So look, if you were to pretend that this is a web server written in Go, and you want to know every time the handler is called. So every time someone accesses your web server, a handler function is executed, and you could use a U probe to tell you every time that handler function is executed. So in this case, that sort of analogy for the handler function is this test function. All it does is sleeps for a second and returns 0. And in main, we're just calling it over and over and over and over again. So just in review, we're going to attach a BPF program to this function using something called a U probe, user space probe. And we are going to print out test function was called every time it was called. And then we could certainly discuss BPF after that, but I'll show you this running. So we'll compile it. So we're compiling the Go code, and we're compiling the BPF object separately. And the BPF object is compiled using Clang. And I'm going to call main. This is the Go program, the user space Go program, and I have it to pass the path to the binary, and then name of the name of the function, which I think is test function. So now every time it's called, we'll get an alert about it. Let me find it, actually. Now I'm actually going to run it, which it calls that function once a second. And we can see here that the BPF program is triggering every time it's called, sending it to user space, and user space is printing out for us. So that's kind of how Tracy works, except way more useful.
Nice.
And you could attach to a lot more things. In the case of both libbpfgo and Tracy, which uses it, you could attach to a whole lot more than user space programs, or functions. You could attach to things like kprobes. So if you're on a Linux machine, you can cat proc kallsims. So this is a file that will tell you every symbol in your running kernel. Every symbol in your running kernel. Like, the kernel is a program just like any other. So, for example, commit creds, you could find this in the Linux kernel source code, and you could attach a kprobe to it and then a BPF program to that kprobe, so that the BPF program is executed every time any process uses commit creds. And that's what BPF enables you to do, among many other things.
But I mean, if more than anything, I'm sure people can see like why this is so valuable in like a production level environment, because like if someone slips in and slips some like malicious code, like Tracy will be able to pick it up like almost immediately, and you'll just know, right? Because as you can see here, even though the code is very simple, sometimes it's all it takes for someone to break into your systems and start doing like weird things, right? But I think Grant did a great job at illustrating like how simple it actually is, but at the same time, like, how powerful Tracy is in letting you know immediately when that does happen. So no, I think that illustrated to me perfectly, because I wasn't aware of how this worked under the hood. So this is definitely helpful for sure.
Yeah. First off, thank you for that. But I will say that certainly a huge most people in I guess anybody in security with like with a Twitter would like to tell you that will like to tell you that security is no, in a good way. I'm not in a
right.
Would tell you that it takes a layered approach to security, that it is very important to make sure that you're deploying code that as far as doesn't have any dependencies, that have vulnerabilities. Use Trivy for that, and write your code as secure a way as possible. But stuff happens, and it's good to have something like Tracy, so that you have that detection at runtime. Things like Trivy and like vulnerability scanners and making sure that you have good dependencies and whatnot go a really long way. But at the same time, like the analogy that I've heard used is like, you make sure that a kid is completely clean before they go outside and play in the mud, but sometimes they're going to get mud on them, and like you have to know about that. And that's kind of like what one of the use cases that Trivy fits into, or Tracy fits into.
No, I like that analogy. No, that's great. Aside from that, talk to us a little more about what just Aqua is doing in the market right now, because I know you guys have been doing a lot of cool things with us in particular. What are some things that people can look forward to from Aqua?
That's a very good question. Yes, someone in sales or marketing is going to be going like that for not prepping me on that. But Samar?
Yeah, so I can help you with that. Full disclosure, I'm not in sales, so I'll do as good of a job as Grant does. So, but I'll try my best. So yes, as we mentioned earlier, Aqua is like trying to basically, like, what we're trying to do here is like detect things that can go wrong as soon as it's possible to do so. So with Trivy, as you saw, we've kind of shortened that path of people deploying their applications into production, and then after the fact running some kind of malware scanner or what have you, and finding out about vulnerabilities after the fact that they've been deployed into prod. So with Trivy, we've shortened that to your laptop, essentially, like the code that you're writing the code on. The laptop that you're developing on is basically the is where you will run your analysis. So with Starboard, we've kind of taken the same trivia approach, but we've done um, um, we've done in the Kubernetes world. So essentially that's what Starboard is. And Aqua also offers a commercial product, or Aqua CSP, as it's called, which essentially is taking the vulnerability scanning approach that we have developed through Trivi and other resources, and taken it to a commercial offering. Now, when it comes to runtime security, which is another aspect, like Grant mentioned, you can secure your builds as much as you want, but things happen.
Right.
For runtime security, we have Tracy, as you saw, but also we have something called Aqua DTA, which is commercial offering as well. So yeah, we have those along the lines of security as products that we offer.
Nice. And then I actually just remember one thing. I've been working with Mansi. I don't know if you guys know Mansi, but we've been working on a joint workshop together that we're going to be running live in July. So if you guys want to learn more about Aqua and some of the things that they're doing, we'll be offering a hands-on workshop later in July. So be on the lookout for that. Besides from that, anything else that you guys want to call out before we sign off?
Yeah, I mean, I just want to say, like whatever we've shown today is out there in open source. So if you want to play with it, if you want to have a chat with us, feel free to either ping us through GitHub, or like by filing a GitHub issue, or using the GitHub discussions feature that is available on the Tracy project. And we're also available on Twitter if you want to reach out through that medium. But then again, we will be happy to see what you can do with the various tools that we have. And it'd be great to see how people end up writing their own signatures to detect all kinds of stuff that we may not have thought of. So if you have any ideas, please feel free to reach out, and yeah, we can have a talk about it and see what we can do.
Solid. Other than that, Grant, Samar, thank you so much for coming on the show and talking to us about Aqua, Tracy, and Trivi. That was extremely educational for me, that's for sure.
Awesome. Thanks so much for having us.
Yeah, thanks for having us. Yeah.
We are here every Wednesday at 2 p.m. PST. So we'll be here next week at the same time, same day. So make sure to subscribe to get notifications for when we go live. But other than that, thanks so much. Appreciate it. Signing off.